volume. All right, we have volume 1, 155 ml, and then we have 185 torr, and that's what? And I just made them both 1 because they were first. Is that okay? If I keep reading, I have what is the new volume, so I'm solving for V2. And means I probably have a P2. If I keep reading, I have a 57.8 kPa. All right, 57.8 kPa. What's the kPa? Is the pressure? Yes. Okay. So the discussion that was going on a minute ago was about the units and making them match. Now, does it matter which unit you pick? No. Some of you were saying, can I change it to torr? Yes. Some of you were saying, can I change it to kPa? The answer is yes. It doesn't really make any difference. So which one did you pick? Some of you chose kPa. Anybody pick torr? Nobody picked torr? Everybody did kPa? Actually, did you do kPa? Really? Everybody picked kPa? Yeah. Everybody went to kPa? Okay, I was going to say, that's like unheard of for everybody to go to the exact same unit. I mean, I guess it could happen because there's only, what, 7 or 8 of us in here, but that would just be weird. Okay? So, if you said, okay, I'm going to kPa, you would have taken your torr and gone torr to kPa. So, what number goes beside the kPa? 101.325. And then beside the torr, you'd have what? 76. Okay? So 185 times 101.325 divided by 760 is 24.6 kPa. All right, so you would have had 24.6 kPa. And if you were what? Huh? It's fine. I don't worry about rounding or any of that. I tend to drop it off, but if you round, that's fine. And if you were one of the people who said 57.8 kPa, and you said I'm changing to torr, like Sheena did, you'd have had kPa on the bottom, torr on the top, 760, 101.325, so 57.8 times. And you got 433.5. And again, I don't send around, so I just drop that off. So you have 433.5 torr. Now, it doesn't matter which set of numbers you choose. You choose the set of numbers or units that you like. So our formula is V1T1 equals V2T2. You pick what you like. So volume was 155. If you're Passion and Eiley, and you said I wanted the kPa number, then you're going to put in the 24.6 kPa equals, I'm looking for V2, and my kPa is 57.8. So that's what I'm going to put there. If you were Sheena and you said, nope, I prefer my torr number, I would have had 185 here, and I would have had 433.5 there plugged in. Okay? Doesn't matter which set of numbers you plug in, as long as they match. But since more of you said I picked the kPa, if I look at just my green numbers to solve for my V2, I'm going to choose to divide by 57.8. 57.8 crosses out or cancels out. 67.8 on this side. Solve for V2. What did y'all get for my second volume? What did you get for the second volume? Y'all solve for V2? 66.1? Is that what y'all got? 66.1, 66.2, 65.9. All of those answers are fine. Okay? The difference comes in and how you rounded in those numbers right there. Okay? Which again is why I tell you show me work. But they're all fine. So for our unit, if you looked here, what unit did V1 have? So you write milliliters on your V2. Any issues with solving? Everybody okay with that? Okay. So, if we do number 2, number 2 says, find the what? Find the new temperature. All right, we're doing a T1 this time. So, if the volume of a gas is this, what's that? Volume, so V1 is 450 ml. At, what did it say we were at? 45 degrees Celsius. So I've got a temperature of 45 degrees Celsius. And again, I made them T1 and D1 because they were first. And if I keep reading, it says, what will the new temperature be? So I'm looking for T2. If I have a volume of what? 675 milliliters. All right, do my volume units match? So I don't have to worry about my volume. Am I good to go on my temperature? No, even though the question says, what is the temperature in Celsius, can I leave it in Celsius? No, it has to be in Kelvin. So I'm going to add my 273 here, and I'm going to get a temperature of what? 318. Okay. So using my V1 over T1 equals V2 over T2, plugging in 450 over 318 equals 675 over T2. Cross multiply, 450 times T2 equals 318 times 675. Divide both sides by 450. Divide by 450. Can you tell me what T2 is this time? You got 400 what? 477. Anybody else get 477? Okay, so that's my Kelvin. Because my units have to do what? I have to match, right? So I got my Kelvin. So the question said find Celsius. So now you're going to use your formula. K equals C plus 273. So my K is 477 equals C plus 273. So now I do what to get my C? Minus 273 from both sides. Cancels there. Minus 273 from this side. And what do I wind up over there? 204. So C is 204 degrees Celsius. Issues, questions about either of the opening problems? Or do we feel okay with those two? Feel okay? Anybody struggling? Got an issue, question, something they want me to talk about? Can we talk about homework? Because Alexa sounds like it's a dying mood. I have no idea. Probably not. I at least had a lot of experience listening to them probably die. All right. So, looking at homework questions. Number 5 should be 140 milliliters. 140 milliliters for the first one. Issues with number 1. Huh? That's fine. This is probably, some of these are probably rounded for significant digits. So if you have like 144 or 141 or 142, this one probably rounded off for significant digits. All right, what was the next one? Because I don't remember the numbers. 10. Number 10 is 121 Kelvin. No, I asked for the next question. Okay. All right, what's after question 10? Okay, question 11 would be 406 milliliters. All right, what's after question 11? Question 14 would be 540 Kelvin. Next. 16 would be 300, nope, that's the wrong answer. 3.4 liters. And the last one was 18, 260 Kelvin. All right, what do we need to do? Talk about. Yes, ma'am. 14? All right, hold on, let's do 14 and I'll do 16. All right, in question 14, it says, to what temperature must a sample of nitrogen at 27 and 0.625 atmospheres be heated so that its pressure becomes 1.125 atmospheres at constant volume. All right, so when you look at this, and number 14, look at the numbers. You see how it says 27 degrees Celsius and 0.625 atmospheres? Those two things are a couple, Isabel. They're a pair. They have to stay together. Oh. Oh, well, that'll mess it up every day of the week. Okay. That'll do it. All right, so number 16. Does anybody need to finish 14? Okay, so number 16. All right, number 16 says, a sample of gas has a temperature of 47 degrees Celsius, 780 mm pressure. So when they say mm, we're talking about millimeters of mercury, even though they only wrote mm. And occupies a volume of 2.20 liters. All right, so that's going to be V1, that's going to be P1, and that's going to be P1. Because they put all three of those things together in the same first sentence, they have to stay together. And as we keep reading, it says what volume would have, so V2 is what we're looking for, if it has a temperature of 107 degrees Celsius and 600 millimeters of pressure. Now again, it only wrote mm, that's the same as mmHg. So we're okay on the volume because it's liters, because we will find it in liters. The pressures match, and the temperatures are in Celsius, so they need to be changed to Kelvin. So, okay, so 320. And 380 is correct. All right, so plugging into our V1, P1 over C1 equals V2, P2 over T2 formula. All right, I have 2.20 times 780 over 320 equals, I don't know, V2 times 600 over 380. So, cross multiplying, I'm going to get 2.20 times 780 times 380 equals 320 times V2 times 600. I'm going to divide here by 320 and by 600. And then divide here by 320 and 600. So, V2 is going to give me 2.20 times 780 times 380 divided by 320 divided by 600. 3.39. Anybody else? Question on anything in the homework? Yeah. Does that make sense, Amy? Okay. Anybody need anything else on the board before I do 11? All right. So in 11, it says at standard temperature. See how that reads at standard temperature, Agwin? That means they're telling you P1 is what temperature. What did we learn yesterday? Standard temperature was. Pull out your blue chart. Okay? See that blue chart at the very top? And more people will not be able to find it. Yeah. As soon as you see the at standard temperature, they're telling you that first temperature is what? 273. Okay? Yeah, that's where most people get tripped up in that question right there. Because they just assume that they don't have that temperature. But they're telling you T1 is 273 and it has a volume of 275. So V1 is 275 milliliters. If we keep reading, if the temperature is increased to 130, so temperature is increased to 130 degrees Celsius, but the pressure is held constant, what is the new volume? So what is the new volume? Well, I don't have my units matching because I've got a degree Celsius and that needs to be in Kelvin. So 130 plus 273 is 403. All right, so now I can say V1, which is 275, over C1, which is 273, V2 over 403. So multiply, so 275 times 403 equals V2 times 273. So divide here by 273, divide here by 273, and we're going to get V2 equals, I'm going to cheat for a second, number 11 was 406. 406, my units have to match, it's got to be over. Okay, makes sense? Anybody else have a question? We feel okay about the homework and where we went wrong? Okay. Now, find your notes. We're going to finish Dalton's Law, and then we're going to practice all the gas laws mixed up before we do our quiz tomorrow. Okay? Quiz tomorrow. Not today, tomorrow. All right? The quiz tomorrow has 5 gas law problems. Tomorrow, because we've done how many gas laws? 5. And there'll be how many questions on the quiz? Because we've done 5 gas laws. So there'll be 1 question for each of the gas laws. That's all you got to know. There'll be no tricks. At least I don't call them tricks, but you know, y'all might. You take whatever. Tomorrow? Yeah, I mean, if you want to come back from school and do it tomorrow while it's fresh and you know it, certainly. The day after school, I can't say today. I need to change that. I was going to, but then yesterday when I got home, my kids said, "Why are we eating dinner?" I said, "What do you mean?" They said, "Why are we eating dinner?" I said, "Well, 8:30, 9 o'clock." They said, "Mom, that is not going to work." So they got really, really, really angry when I told them we're eating dinner till 9 o'clock tonight. Because my son is an all-county band, and he has to perform tonight. My daughter has danced before the all-county band performance. So I had to turn up one or the other, and they weren't going to get done. So they didn't take it very well. Until after the concert, that's why we late. So they got real angry. So they won't be coming with Tuesday night. Oh, what? That's what I said. So then we'll be doing them at the same time. So one has to dance first, and then we have to go from the dance class to the band class. I didn't see the problem either. Oh, my God. I didn't even bring my mark. My wife, I decided to got breaking. I told them to have a snack. All right. So Dalton's Law partial pressure. We're going to do the first half of Dalton's Law, which has the formula on the reference table, and is part of your curriculum. And then we're going to add a piece to Dalton's Law, which is not part of your curriculum, which is some bonus material since you're not in class. I know how much y'all look forward to bonus material because you're not in class. So, Dalton's Law of partial pressure says that the total pressure of a mixture, of gas is equal to the sum of the partial pressure of each individual gas. Right? It's equal to the sum of the partial pressures of each individual gas. The formula that goes with it looks like this. So, what the heck does this formula mean? Well, PT is pretty obvious, I think. That one stands for total pressure. These are the partial pressure. So what do I mean when I say partial pressure? Well, suppose that we have a container. And let's just say that I put some helium gas, some nitrogen gas, and oxygen gas inside the container. Right? What creates the pressure inside of the container? Okay? And they collide. What do they collide with? Each other and the container wall. Okay? So, when helium hits the container wall, and oxygen hits the container wall, and nitrogen does, but then oxygen hits the nitrogen, and oxygen hits helium, and helium hits nitrogen, and nitrogen hits helium, and so forth and so on. And those things hit each other and the container wall. They all create the pressure, right? So how do we find the pressure inside of the container? Well, we add up all of those pressures. So pressure total is equal to the pressure of helium plus the pressure of who else? Yep, plus the pressure of nitrogen. So the pressure that helium exerts is called partial pressure because it only exerts a piece of the pressure inside of the gas canister. Oxygen is considered a partial pressure because it only contributes a piece of the overall pressure inside of the container. And the same for nitrogen. It offers up just a piece of the pressure inside the whole container. But when you add all three of them together, you get the total pressure inside the container. Does that make sense? Now, the only thing you have to do when you're adding them together is to make sure you do what? That's the only catch you have to make sure of before you can add all those pressures together. There you go. Okay? They must have the same unit. That's the only catch. Now, if I happen to say in the question, what is the total pressure in atmosphere? Then you'd have to calculate it in atmosphere. But if I just say, what is the total pressure? Do I care what it's calculated in? No, you can calculate it in whatever you like. Okay? Does everybody have it? Yes or no? Okay. Write that down. All right, got it? All right, got it? All right. So what is total pressure? First of all, what do you notice in the word problem? What's the only thing they give you? So they ask for total pressure. Yeah. What's the only other information they give you in the question compared to what you worked like last night for homework? Just pressure. You got atmospheres, you got torque, you got KPS. So there's no volumes and there's no temperature. So that's one thing you should notice about the problem that makes it different tomorrow on the quiz or next week on the test. What are the gas laws we've learned to work? What did we learn to work yesterday? The stuff. Boyle, Charles, Gay-Lussac. There's 4 of your word problems on the quiz where we learn it right now. Dalton. So there's the 5th one, okay? Okay, so there's your quiz tomorrow. Nobody should be like, what's on the quiz tomorrow, Miss Wall? You now know. All right, so. Well, you know, I didn't give you a quiz today. So when do you suppose you'll see that information? Where will you see that? So it'll be on the. Yeah. All right, so there's our formula. 10 multiple choice, 11 word problem. You like it when I do what? Yes, but there will be some people, every year I have the same problem, who struggle to finish that test. So I really can't put word problems on the test. They're like these. I mean, yes, tomorrow I've blocked in our plan 30 minutes for the quiz. Y'all will probably finish in 30 minutes without difficulty. First period, I'll be trying to snatch people's papers out of their hands. Get 30 minutes. Even on test day, at the end of an hour and a half, I usually have 4 people still sitting here, and I'm literally shoving them out the door, going, you have to go to class. All right, so we're looking for P total, and we need 3 partial pressures because I have 3 pressures, right? So I have 2.5 ATM. I have 653 torque, and I have 152.3 kPa. Now, the problem I have is what? They're not the same unit. Now, the reason I do this, because some of y'all are going, why do you do this? Is I need to make sure you convert units. Well, instead of giving you separate questions on the quiz that ask you to convert units, I get more bang for my buck in this question because I can check to see if you know how to convert units when I give you separate questions. But I can't. So, which unit would you like the pressure to be? 4. Okay. Okay. Now, I will tell you that when we get down here to PV equals an RT tomorrow, we've got to change the atmosphere, so some of you will gravitate that way by the test. The source time for today. So we're going to leave 653 torque as is, and the other ones have to be changed. So 2.5 ATM, ATM on the bottom, and 4 on the top. So ATM gets what number? Yeah, and 4 gets? We'll worry there for a minute. So 2.5 times 760 is 1900. All right, and 152.3 kPa. And 4 will give us 101.325 and 760. Okay. If that ever happens in my class, you can start to, I hope somebody comes to rescue me. Just no one comes to help. Okay? Any issues with how to do that? Ah, we have one to go. Now, this is our extension part given your honors class. All right? I know, we'll talk. Everybody got it? All right, we will only use this formula if the word problem says gas collected over water or by water displacement. If the word problem does not talk about collecting a gas over water or by water displacement, we will not use this formula we're getting ready to use. Okay? This is a very narrow type of formula, but most gases are collected over water. You actually bubble the gas through a water hose, collect it. Because of that, you have to calculate it a special way. So, because of that, you have to calculate the amount of pressure exerted by the water. Water actually exerts a pressure on the gas. So, the formula we use is P total, which we just calculated. So this is still pressure total. This is partial pressure. And this last one is a new one. Right? This is the pressure of water. This is found on a reference table. Right? This is found on the reference table. And it's based on temperature in the word problem. Right? It's based on the temperature in the word problem. So, if you have to have a reference table, I have to give you one. The same on this. You got it. You good and bad. So, sometimes let's hope you get free guys. Figured out the pressure exerted by a gas at all these different temperatures. So, why anybody would want to do that? I have no idea. But it is. But we know the pressure of gases at all these different temperatures. Now, this chart is just a sample of all these temperatures. I did not use a full chart. So, we want to be able to find total pressure and partial pressure. Is everybody caught up? Now, I warn you. That was something wrong. That's really short. But we're only writing one. So you're all moaning like crazy. And it is the last slide of notes most likely for the day, unless y'all just are really fast workers when we get to number 4. Okay? So, write your pencil down. We're going to talk about how to work without one. Not playing so like the last 2 minutes, you take notes all day. Okay, we're going to have to take notes a couple more minutes. You can work slowly on the map. Broke your leg. Why did you fall down? All right? All right. You there? All right. So, what does this question tell you if we just go with this work? All right. When you look at this, did everybody see where it says selected by water displacement? Okay. So this one's the one that tells you you're going to use P total equals P gas plus P water. Now, the easiest number to find is the P water. Okay? This one right here is the one that's always on the reference table. You don't have to find it in the word problem. The pressure of the water is not ever given in the word problem. It always comes from the table I just gave you. Okay? You use the 20 degrees Celsius to find this. Okay? So on that chart that I just handed you, find 20 degrees Celsius. Have to put it up. Can't read. So pull it back out. Now, there's two columns. There's a KPA column, and there's this MMHG column. So you have to figure out in the word problem, did I give you MMHG or did I give you KPA? And I gave you what? MMHG. So find the MMHG column and find the temperature column. So I gave you 20 degrees Celsius and I found MMHG. So read down and over just like you would on a graph until they meet, and what number do you find at 20 degrees in MMHG? Does everybody agree with Eiley and Andy 17.5? Okay. Anybody not able to find it? They got 17.5 and need help. Did you see how they got that? Oh. That's why you can't find it. On this. All right, 20 degrees Celsius. And pressure than MMHG KPA. And this column MMHG. We then you get to 20 and the MMHG column. And 20. There. Okay. Now, that means these two numbers come from the word problem. One we're going to find, one's going to be given. Now, when you read the question, what was the partial pressure of oxygen? What are they asking us to find? Which one is the partial pressure? PT or P gas? So we're looking for P gas. That means the 731 has to be the what? Total pressure. So, what are we doing in order to find P gas? We're subtracting. So subtract 17.5, subtract 17.5, and get your answer. So, 731, subtract 17.5, is what? 713.5 millimeters of Hg. And then you get your answer. Everybody go with that? You can write equals P gas if you want, but it's MMHG. I don't care if you write what variable it's equal to. It is. I think Dalton's one of the easiest ones we ever do. All right. You think you can try one on your own? Okay. Don't write this one. You already got a sample. There's no need to write it. Okay. Just solve. Okay. Don't write it. You already have one. Just solve it. Okay. Just find the answer. Read and solve. Huh? No, I want you to wait a half hour and then do it. Building and mercury. All right, we there? Okay, so what did they ask us to find this time? Are we asked to find P total, P gas, or P water? Okay? They said here the partial pressure was determined to be. So we're looking for peepholes this time. So partial pressure is 742.5. And where do we find P water every single time? On the sheet. And because I told you again the temperature was 20, it's still what number? When you add, you get a total of. And because these units are still mmHg, you still have mmHg. Question? No? Most fabulous. All right. So that we can practice and be in good shape for the quiz tomorrow, we're going to do the same thing we did first period. Just have old school. I did it, but it works for me. And what? I know, old school. All right. You're going to need to write this down on your worksheet because I'm going to print a couple things and I'm going to need to take this off the board. All right. We're going to do questions number 1, 2, 5, 6, 9, 12, 14, and 16. It should be 8. Yeah. And I think I have one of everybody in there. I don't think I've omitted any of the 5 laws. Okay? If you can do those 8, you should be able to do everything on the quiz tomorrow. Now, up here in front of the computer are the answers so that you can check yourself as you go. Okay? You also should be able to finish this before the bell so that you have what? No homework. Okay? Should be able to. It's highly unlikely. Okay. There's not a lot of space on that, so could be what? Yeah, we need a notebook. I don't want it.